In this video, we'll talk about how we can use Spring Boot in Java to create a REST API and also learn about different concepts and tools which Spring Boot provides to build a better application and build better web services. So, in this video, we'll talk about how we can create a Spring Boot project and also run a Spring Boot project and see the server running. So, the best part about Spring Boot is that you don't need a Tomcat server running separately and have a Java project connecting with it. Everything is provided by Spring Boot. All you have to do is know the basics of Java and some basics of Spring. So to continue or to watch this video, make sure that you have some basics of Java in your pocket and also some basics of Spring. You can find them in the programming knowledge channel. And once you're done with that, you can come ahead and start watching this video. So in this video, we'll talk about how we can create a Spring Boot project. So for that, the first thing which you need is an IDE. So the IDE which we're going to use for this video is Spring Tools Boot. So it's by or for Eclipse and it's completely open source. So go ahead and download the one which you have for your operating system. I have a Mac, so I had downloaded the Mac 64-bit Spring Tool Suite. And yeah, so once we are done with this, you can start following the tutorial. And so this is how your Spring Boot tools look like. So we'll be creating a REST service or a REST API. And this is going to be the hello world of REST API, which is going to be a to-do list API, where you can add tasks to your to-do list, you can delete them, you can update them. So you'll have all the CRUD operations, which is create, update, and delete. And we'll be building that using Java, Spring Boot, and we'll see how we can connect to the database, a MySQL database, and also see how we can work with REST services. So what is a model view controller, the MVC architecture, and how does that work? So we have a lot of cool things going to happen inside our tutorials. So keep watching and let's start first creating a Spring Boot project, which you can use to actually start building up on top of your Spring Boot application. So I have my Spring Boot Spring Tool Suite running, STS for short. And what we're going to do is we're going to start a new project. So it can be anything. It can be a Java project, a Spring Starter project. But the most easiest way or the most comfortable way I know to start one is to create a Maven project. So go to Other, click on Maven project, go to Next. And we'll be creating a simple project and we can build on top of that later. So we have a very simple project here. Go to Next, give it a group ID. So group ID is basically a name for what you want to do. So we'll just call it to-do list. To-do list. The artifact ID is going to be the same. And we'll let the version be 0.0.1 snapshot, nothing against that. And the name is going to be again to-do list. No need to give a description here, and we'll add a parent later. So simple naming conventions to our project, a to-do list API. So we'll have it the name as to-do list. When we click on finish, and we have a to-do list project here. So as you can see, we haven't added anything to our project right now, but there's still a lot of things here. So we have a JRE system library, we have Java resources test folder, a POM.xml. So we'll talk about what Maven is and what POM is. And before all of that, the one thing which I forgot to mention was that you need to have, which is unobvious, you need to have Java installed in your computer. So make sure that you have Java. So you can just do Java dash version and make sure that it's 1.8 or above. I don't know if there's another if there's a newer one than 1.8, but make sure that you have Java installed and you have it, and you can confirm it by running Java dash version. Great. So now that we have created our to-do list project, a Maven project. So Maven is basically a single point of repositories where you have all the jar files. So if you want to add any jar files to your project, add an API or add a framework or a jar, you can do that by using Maven, and especially this POM file. So the POM file basically acts as a way for you to download jars in your project by giving the POM file the name, the version number of the jar which you want, etc., etc. So this is how you actually do it. And we'll be filling up our POM file first. Make sure that we have all the things which we need to start our project. So let's start by doing that. So let me just quickly open the POM here. So first thing which we need is a parent tag. So I'll talk about this in a minute. So this is a parent XML tag, and parent is basically Spring Boot starter parent. So this tag tells the project that the project is a child of the Spring Boot parent jar. So this tells the project that we'll be using Spring Boot, and this is a Spring Boot application which we're going to build. So again, group ID, artifact ID, the names, the version, etc., etc. And this is how we tell our project that this is a parent project or a child project of the parent, which is Spring Boot. Okay. The next thing which we need is simple dependencies. So dependencies are basically the jars which is going to help you get automatically installed in your project, and you can just use them directly. The first thing which we need is Spring Boot Starter Web. This is basically provides you with all sorts of annotations and functions which can help you quickly build a REST API or web services very, very, very easily. And after this, another thing which we need is the properties tag. Allocate some properties to our file. So we have properties Java version 1.8, as you guys know. Just hit refresh and make sure that everything is stable. And before we complete, the last thing which you need to do is basically update your project. So go to your project, right click on it, and go to Maven and click update project. Okay, just to make sure that your dependencies are downloaded and your POM files are ready, and to make sure that your properties is 1.8. Okay, so great. We have updated our Maven file, Maven project, a POM file. So POM file has three things. First is the parent, which is a Spring Boot starter parent. Next is dependencies, which is Spring Boot starter web, which gives you all sorts of annotations, functions. And the last thing is properties, which is the Java version, which you're going to use inside our project. Okay, the next thing which we need to do is create a starting point for our Spring Boot application, which basically runs the server. So once that is done, we'll actually have our server running on top on port 8080 localhost and see how that works. So let's start by doing that. Let's start doing that now. So in your src main Java, right here, we're going to create a new class, which is going to be to-do list. Let me just say to-do list. Yeah. So this particular class is going to be having a main function, main method, because this is the starting point of how we actually run our Spring Boot application. So click on finish, and we should be good to go. Give it a minute. And great. So now we have a to-do list starting point for our project, and all we need to do is just have a couple of annotations to actually run this. So to actually make this Java project a Spring Boot project, so make sure know that this is still a Java project. We have downloaded and installed the jars and dependencies which we need on the POM file, but we haven't actually used them. So it is still a Java project or a Maven project. So now what we do is make this a Spring Boot application. So for that we have some annotations. So first we do is Spring Boot application, and we import that. So if you just hover on top of it and you just do this, now this has officially become a Spring Boot application. And the next thing which you have to do is basically run it. So you say Spring Boot application dot run. So let me just quickly see what this was. I keep forgetting the syntax, so sorry about that. It's a Spring application, my bad. So we have booted it, so we just do Spring application dot run, and we have two arguments here for our run method. First is the source, basically which is going to ask us or tell the project where to run or what class to run. So we'll be running the to-do list.java file, the class. So we just say to-do list.class. and the arguments are going to be args which can be passed running the project right from here. So this is how we actually create or develop a Spring Boot project. Now let's run this and see what we get. So we'll be running it as a simple Java application because the annotations handle the Spring Boot part of it. So we don't have to worry about that. Press OK. And we just wait for a couple of minutes. So they should be showing on the bottom, but I have it on top because I think it's easier to see what's running and what's not. So you don't have to worry about that. So now when you scroll here, you see that the Tomcat has started on port 8080. So we can go here, go to 8080, click enter, and so we get a white label error page. So basically, we just ran a server, so we don't have anything yet on the server. And when there's nothing, Spring Boot goes to the error/error page. And as there is no explicit mapping for the error page, you see this as fallback. This is a default by Spring Boot. So don't worry, you haven't done anything wrong yet. It's perfectly working. The Spring Boot server is on, and you have a web service already there. The server is up without anything, any much effort. All you have to do is now keep adding stuff to it so that this becomes a fully fledged REST application. So that's it for this video. In this video, we talked about how you can actually create a Spring Boot project efficiently, and in the next video, we'll talk about how we can create or implement a REST controller using Spring Boot and keep continuing this tutorial. So just to reiterate on what we had done since the beginning, first we install Spring Toolsuite for Eclipse, open source, anything works here. Next, you create a new project. So go to File, New, go to Other, and create a Maven project. After you're done with that, go to your pom.xml, and let me just close this. Yeah, go to your pom.xml and add the Spring Boot starter parent as your parent ID, and add the dependencies of Spring Boot starter web, and make sure that your Java properties are 1.8 so that this is ready to actually start building up your Spring Boot application. In this video, we'll talk about how we can create a Spring Boot application and also implement a REST controller. So in this video, we have a to-do list API, which basically can perform CRUD operations, create, update, delete, using Spring Boot, which we'll be using to develop our REST API. And in this video, we'll talk about how we can implement a simple REST controller. So a controller is basically a Java class where you can handle URLs and API endpoints, which then passes on the logic to the service or to the model. It's the database. So controller is your starting point to your URL and how we can actually work with a URL or an API endpoint. So let's get started. We'll be making a very simple get request using a controller. And a get request is basically when a client asks something or gets some data from the server. So if I want to get a task or get all of my tasks from a to-do list, I do a get request, and then that fetches me a JSON or any other thing which then acts as the data which we get from the REST API or the server. So let's get started. First, we need to create a class. So go inside Java, src main Java, and here go to new class, and this is going to be inside something called as hello. So we'll be making a get request called as hello, and we get back let's say namaste from the server. So let's see how we can implement that. We'll call this hello controller. So a very common naming convention in Spring Boot, being very opinionated, is that you need to, it's good practice to have the controller name inside your class whenever you're implementing a controller. So, which tells the user that this is a hello controller. Great. So we don't need a main method here. We just need hello controller, and all we can do is press finish. And here we have it. We have our controller now. Again, this is not a Spring Boot REST controller yet. It is simple. It is just a Java file or Java class. So we have to annotate this to let Spring Boot know that this is a REST controller. So for that, we do an @REST controller, and we hover on top of it, and we import it now. So now basically now our controller is a REST controller because we annotated the class with it. So this is how when Spring Boot on starting up, it does a class path scan. It basically scans all your classes and sees all the annotation on top of it and then acts accordingly. So this is how you tell Spring Boot that okay, this is a controller and everything inside will be having API endpoints. Great. So now let's start developing our first controller or implementing our first controller method. So we'll be doing a request, a get request. So for that, we need to have a way to map that request to a function or a method inside our controller. So again, Spring Boot provides you with something called as request mapping. So you use request mapping to actually map your endpoint to the method. So let's do request mapping, and we go to /hello. So we will have to implement or get this. So let's give it some time. And we have a public string say hello. Great. And let's import request mapping. Awesome. And we return namaste. A very simple controller which greets you when you ask or request something or ask for a hello, right? Nothing complicated, nothing complex, just a simple controller. So here, what happens behind the scenes is that whenever you access localhost port 8080 or base URL /hello, that /hello is mapped with this function, the say hello function, and it returns back namaste. So in this video, we'll talk only about how we can return a string, but in the upcoming videos, we'll actually return objects and much more complicated data structures than just a string. So here we use the request mapping annotation to have a /hello mapped to the function, and as you can see, Spring Boot makes it really easy. And if I have to actually go all the way and say it makes it as easy as Python to actually develop REST controllers. So it's as simple as this. You have a REST controller annotation and a request mapping annotation. You have a function, you have a return value, and you're done. So you have a get request working completely fully without any other thing to do. And all we have left to do now is to run this, and we can see that when you do a /hello, it returns back namaste. So let's try that. We do go here and we run it. So give it time. It's really nice ASCII art here, so I really like that. Okay, so application failed to start. Why is that? Verify entity stop the process. Okay. I already might have something running, so yeah. So let's stop everything. My bad. And okay, now that we have stopped everything, we start it again. We really shouldn't have got lost on that. Okay, so now I can see that Tomcat has been started on port 8080. So we had our previous server running. So now when you go to localhost port 8080, not 808, 8080. Yeah. So again, we get this page, but when you go to a /hello, we get a namaste back. So this is how you implement a REST controller using Spring Boot, and this is a very simple tutorial, a very straightforward tutorial. In this video, we'll talk about Spring MVC Framework, which is the model view controller framework, and we'll also talk about how entities can be made in a Java or a Spring Boot application. So in the previous video, we talked about how we can create a simple REST controller, and we also talked about how we can actually create a Spring Boot project. And in this video, we'll actually dive deep into the concepts behind a REST API and behind how Spring Boot actually is used to implement a REST API and all the
magic that happens behind the scenes when you open a website. So what is a business service, and what is a controllers, and why do we make controllers, and what's the abstraction? So we'll talk about all of that in this video and the upcoming videos. So the main topic for this video is going to be Spring MVC Framework, which is a model view controller framework. And after that, we'll actually start implementing our REST API, which is a to-do list API. So we'll talk about how we can implement a to-do entity, and we'll see how that interacts with the rest of our application in the future videos. So let's begin. So first, we talk about the Spring MVC framework. So the Spring Web MVC framework provides something called as a model view controller architecture, and it's already ready with components that can be used to develop flexible and loosely coupled web applications. So it's not tightly coupled. So you have a lot of things which you can optimize and customize according to your needs, and you don't have to always follow something which is opinionated. So what are the three things inside the MVC framework? So the first is the model. So as you can see here, the model encapsulates the application data, and in general, they will consist of Pojo. So Pojo is a plain old Java object. So usually, model is basically a database. So your a Java object. So if you have a plain old Java object, that is then converted into a row in your database or a database schema, and then we use that to actually talk to our application, talk to the controller, or talk to the view using a model. So the model basically encapsulates the data which the application uses. So here in our to-do list example, which we're going to actually implement, the model is going to be the name of the task in the to-do list, the summary of the to-do list, and the description of each task in the to-do list. So yeah, that is what model is. The next is view. So the view is responsible for rendering the model data, and in general it generates HTML output that the client's browser can interpret. So let's map the understanding of view with what we're going to implement. So view generally is considered of the HTML output. So basically this framework which you see here, this website which you see here, whatever the buttons and everything is the view of the application by tutorial's point. But since we will be creating a REST API, our view is going to be simple JSON, JavaScript object notation. So that is going to be our view, which can be interpreted by some browsers and some not. But we'll be using Postman, which is used for handling APIs. So we don't have to worry about the view as of now. The next and the most important part, I feel, is the controller. So the controller is responsible for processing requests and building an appropriate model and passing it to the view for rendering. So the controller takes in the data from the model, and then has the business logic inside it, or the business service, and then it passes it to the view for rendering. So what happens behind the scenes? So the Spring Web MVC framework is designed around a dispatcher servlet class that handles all the HTTP requests and responses for you. So you don't have to worry about all of that. You can just focus about your problem which you want to solve. So the workflow is as follows. So after receiving an HTTP request, so let's say you have a GET request where you want to get some data from the server. Let's say you want to get all the tasks in the to-do list. So the dispatcher servlet consults the handler mapping to call the appropriate controller. So the controller here is going to be get to-do list or get all to-dos. Now the controller takes the request and calls the appropriate service methods based on the used get or post method. So we will be having a service method which actually talks to our database or talks to our model to actually get that data and then give it back to the view. So the service data will set model data based on defined business logic and returns view name to the dispatcher servlet. Now, the dispatcher servlet will take help from view resolver to pick up the defined view. So we don't have to worry about this step for our implementation because we'll be having a JSON output. Now, once the view is finalized, the dispatcher servlet passes the model data to the view, which is finally rendered on the browser. So all the above components, the handler mapping controller, are parts of the web application context, which is an extension of the plain application context. So we'll talk about all of these annotations and all of this context in the future videos, but just remember this diagram and how the MVC works. So M is model, your data mainly. View is how we actually see the application. So we'll be having simple JSON objects in our view for now. And controller is where you actually handle requests and figure out the business logic for your application. Great. So we'll be building our web application around the MVC framework. So we need to know how this works before we actually dive into the implementation. Now let's start actually building our to-do list REST API using Spring Boot. So let's close the hello package. So we don't want to use this. So it's just an example. And let's actually create a new package. So go to src main java in your to-do list. Go to new. Go to package. And this is going to be to-do list dot to do. So this is what will be named our package. You can name it anything, but I think this is the most easiest one to name. And next we need a simple class. So now the first thing which we have to do is create an entity, a to-do entity. So an entity is basically a real-world object in database. So in databases, it's a very common thing to talk about entities, and we'll be mimicking that in a Java class. So this class will contain all the information about a to-do object, right? A to-do entity. So what will the to-do include? So a to-do or a task will include an ID, a unique ID, which can be used to access any of the to-dos or the tasks. It will have a name. So the name of a to-do, for example, create a YouTube video or finish the project assignment. So the name of your to do. The next is going to be the summary or a very short gist of what the task is about. And if you actually have a really important task to do, then you will also have a description which you can actually elaborate how you are actually going to uh, finish the task or what the task consists about. So let's start making our to do entity. So we'll just call it to do. So to do and press finish. Great. So we have our to-do class here now, and let's add some things which we talked about here. So the first thing which we need is a unique ID. So integer ID. Next is string name. So this is all we need inside our entity, but we also need to have setters and getters in simple Java concept for this class, and also have a constructor. So let's do that now. So what we do is go to source and click on generate getters and setters, and let's select all because we need it for all of them, and click generate. And yeah, we have it here. So pretty neat, pretty simple method of doing it. And now what we need are two constructors. So we need an empty constructor and we need a parameterized constructor. So let's make that now. Go to source and generate constructor using fields. Select all and done. So now we have a parameterized constructor here, and we need to actually make sure that this also has an empty constructor because it makes it easier later. So let's copy this now. And let's remove all of this to make it empty. And great. So now here we have a to-do entity. So it has the ID, name, summary, description. It has constructors, and we have getters and setters. So if you ever want to make a task, this is the class or the object of this class is what we'll be using to create our to-do list objects. So yeah, that was it for this video. We talked about the MVC framework. We talked about model, which encapsulates application data. We talked about the view and controller. So view is going to be JSON for now, and the controller is where all the business logic and mapping of the requests happen. And the dispatcher servlet also helps you behind the scenes to actually handle all of this for you. So yeah, after that we talked about the entity which we'll be using to make our API. So this is a very basic entity. So everything that happens inside the application will be using this to actually make our tasks in the to-do list. So we'll have a unique ID, name, summary, and description.
In this video, we'll talk about how we implement a GET API, and we'll actually start implementing our REST API. The first API which we're going to actually target is the GET API. So before we jump on to in the implementation, let's first talk about how we'll be doing it. So for a few videos for the API endpoints, we will not be adding a database yet. We will only be having our database in memory with just objects. And later in the future, once we are done with how the controller works or how the business service works, after that we can then talk about how we can integrate a database, a MySQL database into our application. So until then, we'll be having an in-memory database to work with, which will actually mimic how our actual database takes place. So until that, we'll just focus on the controller and the service or the business logic, which we'll be creating for our to-do list application. So in the previous video, this is where we were. We had our to-do entity and we had constructed the getters and setters and the constructor for it. In this video, we'll actually go ahead and actually start making our to-do list API. So now again, we need a new class for our controller. So go to the package and click class. This is going to be to-do controller. Finish. Great. And now here we need to have two methods. So the controller is basically what talks to your request URL. So if you have a to-do list.com slash get all to-dos, so that actually, or the slash to-dos, that actually gives you all the to-do list tasks. So the controller takes care of that, and we'll see how that works. So let's create our method. So we have a public list of to-do, and there's going to be get all to-dos. Great. So let's import the necessary functions. So here we have the list from util, and we return the list of to-dos whenever you ask this. Now, how do we actually map this to the URL? So as we saw in our the second video, right, how to implement a REST controller here. So we have to give it a REST controller annotation and also the request mapping annotation. So let's do that now. So to make this a REST controller, we have to give it a REST controller annotation. And we again import it. And to map the request with this method to slash to-dos, we need to do a request mapping. And the mapping will be done to slash to-dos. Oh, my bad. And let's import request mapping as well. Okay, great. So now we have a method called get all to-dos and which is mapped to slash to-dos, but we need to return a list of to-dos now. So how do we do that? So the one way could be to actually implement a logic right inside here. So we can just write the logic here and then return that right now. But things are a bit different here. So this is a controller class, so it only deals with the controller and not the business logic or the service, also called a service or logic. So the controller only takes care about how logic or how the data is actually sent back to the view, right, which is the JSON. So we will actually have a service which actually deals with the business logic of getting all the tasks, etc., etc. So let's implement our service class, which is the to-do service. So go again, let's close this and go to to-do, new class, and we call it to-do service. And let's create it.
So this class will contain all the business logic which we have to have to actually give back the controller some data. So here first we need a list of to-dos, right? So we have a private list to-do called as to-dos, and this is going to be an array list. So new array list, and let's actually implement our array list, right? So this is going to be arrays dot as list, and let's have a few lists here. So the first thing which we have is a new object, so new to do, and the ID is going to be 1, the name is going to be task 1, summary is going to be summary 1, and description is going to be description 1. Yes, so let's just make a few more so that we got enough to work with. We'll call this 2 and 3, and let's import our list. Great. So now how do we actually let Spring know that this is a service? So how do we let Spring know that? Similarly, how when we talk about this being a REST controller, we need Spring to know that it's a service, so that Spring can do a class path scan and then understand that this is a service, and all services are singleton. So Spring only creates one object of this service, and then it keeps using it so that it saves time and space. So to do that, we just have a service annotation, and this lets Spring know that this is a service. Great. Now we have a to-dos list of to-do. So it has 3 tasks: task 1, task 2, and task 3. So let me just fix that right now. Task 2 and task 3. Let's do it for this one as well. So it's going to be 2 and 3. Great. So great. Now let's actually implement our method or the business logic. So how we do that is we do a public list to do get all to-dos, and we return to-dos. So pretty simple, pretty straightforward. And now we have the logic here for get all to-dos, which just returns all the to-do list objects. And now we need a way for this to be injected into our controller. So let's see how this works. So we do a private to do service. We create or instantiate a class variable to do service, and to inject all of this inside our controller, we have an auto-wired annotation. So we'll talk about what auto-wired is and what dependency injections are. So basically, the service is dependent on the controller is dependent on the service, and we want to use the service inside our controller. So we talk about how we use dependent injection in a later video, but let's see how this works now. So now that we have our to-do service, all we have to do is do to-do service dot to-do service dot get all to-dos, and we're good to go. So this is how we actually get all the to-dos, and let's run this and see how this works. So we are inside to-do list. So cancel, go down to-do list. Okay, let's see how this works. Just run. Could not find to-do list dot to-do list. Okay. let's write here Java application. Great. Yeah. So let's wait for the server to be spinning up, and then we can actually test this to see if it works. So as you can see here, we have our to-do list ready. So let's go to our browser. So let's go here and let's go to port 8080 and let's see slash to-dos. So here, as you can see, we have our task 1, task 2, and task 3. So I named it wrong. But yeah, so we have our 3 tasks here, and this was with the help of the method here. So if I close this and cut it out, so here we had a slash to dos and we had a to do service. So let me quickly fix this. So we have 2, 2, 2, and 3, 3, 3, and this is going to be 2, and this is going to be 3. Great. So this is how we actually implement a get API, and now let's actually have a get API for getting it by ID or just getting one to-do list. Or so we do again a request mapping, and now we don't want only the to-dos, we just want one to-do, right? So we just want the ID, but the ID here is a variable, right? It's a class variable called as ID. So to actually have variables inside your URL, we use curly braces and we put our variable name inside that. So now whenever you have an ID 1, ID 2, ID 3, it will be mapped as slash to do slash 1 slash to do slash 3. Okay, so we do a public do get to do, and this will have the integer ID. Now we need we need to tell Spring Boot that this ID is the same as this one inside our URL. So for this we have an annotation called as path variable. So path variable basically tells Spring Boot that this one, the ID here, is going to be mapped to the ID in the URL. And all we have to do is do a return to do service dot get to do and pass in the ID. So we haven't implemented get to do yet. So let's do that right now. So we create a method here. Great. And all you have to do is return to do's dot convert it to a stream, and then we filter the stream. So the filter is going to be a lambda expression. So for every to do, every task, we have to get the ID and check it if it's equal to the ID which we pass. And if it is, then we do a find first. So we find the first one and we do a dot get to it. Oh, sorry. We'll find first and dot get. Yeah. So let's see what the error is here. Types mismatch for a stream. Oh, okay. So we need to do start filter. Okay. Oh, my bad. Yeah. Okay. So stream dot filter equals ID dot find first dot get. Yeah. Great. So here what we're doing is we are filtering all the to-dos, getting each of them by ID, then we compare it with the ID here and get the first one which we find. So how does the workflow look like? So we have the to-do slash ID, we have the integer which is passed into to-do.service, and we get the ID. We go to the service and we filter it by the ID and check if the ID matches anything inside here, and we get it back. So this is how we get one single to do using the ID. So let's run it again and see how this works. Run as Java application. Up in no time. So yep. So we have our server ready. So all we have to do is do /1 and we get the first to do now. So as you can see, we have the first to do. We go to 2, we have the second one, and when we go to 3, we have the third one. And if we go to just /to-dos, we have all of them here, as you can see. So this is how a get API works inside Spring Boot.
In this video, we'll talk about how we can implement a post API in our Spring Boot REST API application. So in the previous video, we talked about how we can implement the get API. So where we get all the to-dos from the server, or we get a particular to-do which is by the ID from the server. So let's just refresh what we had done in the previous video now. So we had built a business service or a to-do service which handles all the business logic for our application. So for initially, we now have an in-memory database where we have objects inside an array, but later in the videos, we'll actually convert to a proper database, and then we'll actually use the JPA APIs and etc. for our database. For now, we have a simple in-memory database, and the logic for our APIs is here. So for getting all the to-dos, we just return all the array list, and it is automatically converted into JSON when we return it back to the view. The next thing which we did was we had implemented the get to do, which gives you a task based on the ID, which is unique, and we use streams filter to get it. So we had converted our array list to a stream. We filtered it by the ID, which is equal to the ID given, and then we got the first one which matched the ID. Now, in this video, we'll talk about how we can implement a post API and what we have to do and the kind of business service that we have to write. So let's get started. So now, to do a post API, there are some changes which we need to do in the annotation for the request mapping. So let's see what that is now. So we need a request mapping because we need to map the request. So request mapping, and we do. And now instead of just this one, what we have to do first is we need to tell Spring Boot that this request mapping is a post mapping and not a get. So all of these are get by default, but we need to specify explicitly that this one is post method. So for that, we have an argument called as method, and all we have to do is make it to the request method called as post. So request method dot post. And now the next thing which we need to do is pass in the URL where we have to give out the post request. That is going to be /todos only. So let's see how this works now. So now we have our usual post method. So public void create to do, and now we have a request body. So we will have a request body where we actually pass in the JSON to create a to do, and the JSON will contain the ID, name, summary, and description. So here we need a to do object called as to do to be passed into as parameter, but the to do has to be the request body. So we need to let Spring know that whenever you go on to /to-do and pass in a request body, that should be given to this method in the argument, and this should also be the request body. So for this, we have an annotation called as request body, which makes it really easy to actually pass in these. So let's import these now. So we import request body, and let's import request method, and we're good to go. So let's see, invalid, oh sorry, the value is equal to this. Yes. Yeah. And now all we have to do is call our service to handle the creation of the task for us. So we do a return to do service dot create to do, and we pass in the object. Now we haven't implemented our create to do yet, so we need to do that now. And just so we are clear about the controller, we have a request mapping where the method is post. So it's pretty straightforward, right? So we have a post method, we have the value as slash to do's, but will be having a request body to it. So the request body is a to do object which will be written in JSON, and Spring automatically converts it to a pure POJO. So we don't have to worry about that. And then we have a business service method here. So let's create that method now. So instead of object, we can have to do. So now here we will be implementing the logic for our create request. So we do a return to do's dot add, and we add the to do. So pretty simple, pretty straightforward for now, nothing complicated. And let's see what the problem is here. Oh, sorry, this is a void. My bad. And we don't have to return anything, we just have to create it. Yes, because the return value is void, we don't have to send. You can send in a boolean, so you can send in a true or false. So you can just check whether if it is successfully created, so send a true, or if it is not, and if it actually raises some error, then then send a false. So we'll be adding a lot of validation to our request later in the videos, but for now let's see how a simple post request works. So here all we have to do is add a to do to our array list, and that's it, we're done with creating to dos. So this is how you implement a post request in a Spring Boot application using the MVC framework. So let's refresh our memory and let's see what we have done here. So we have a controller, a to do controller, which injects a to do service, and the service handles all the business logic for our application. Next, we have the request mappings for the URL. So what happens when we do a slash to do's? We go to the method get all to do's. We call the service method, which is a singleton. So the service method returns all the to do's which are inside this. So 1, 2, 3. And next, we obtain one by the ID, which is a path variable integer ID. Then we go to get to do, and we have the logic here for it. The last thing which we do is create to do. So we do a create to do, and we just add the to do to our list. So let's run this and see if our post API is working properly or not. So for that, all you have to do is go to our to-do list and run as Java application. So the Spring has been released to the server and should be up in no time. So just give it a few seconds, and yeah, we're good to go. So now instead of using the browser, we'll be using Postman. So let's actually start using Postman now. So Postman is basically an API tool or a software which can help you handle APIs properly, so you don't have to worry about using something else. So now that we have our server running, we can send a GET request to to-dos and hit send. And as you can see, we get our we get our to-dos here. Now let's do a post request. So when we do a post request, we have to change a few things. So first we need to set the content type as JSON, which tells that we're going to actually pass in a JSON object or a JavaScript object. And here I have a body. So since we only have 3 tasks in our to-dos, let's add a 4th one, which is task 4, summary 4, description 4, and we press send. And we don't return anything, but we get the status as 200. So let's do a get and see whether we have actually added our 4th one. So as you can see, we have the 4th ID here. So that means
the fourth to do was added to our list of tasks, and that can be confirmed with the body which is returned when you do a get. And yeah, so that is how you implement a post API in your Spring Boot application.
In this video, we'll talk about how we can implement the put and the delete request for our Spring Boot REST API application. And we'll see how we create the controller and also the service for this. And we'll run it on Postman and see what the output is. So just to give you a brief recap of what we have done in the previous video. So we are making a to-do list REST API Spring Boot application where we have a to-do list API which we are going to create, which is going to have things like creating a task, updating a task, and deleting a task. So the CRUD operations that can be performed in a simple REST API, but using Spring Boot. So in the initial videos, we made our to-do entity where we had a simple to-do class and we had the attributes or the variables for the class, which is ID, name, summary, description. We had generated the getters and setters and also the parameterized and non-parameterized constructors. After that, we talked about how we can do a dependency injection into our Spring Boot application in the controller, where the to-do service is a singleton and how it works behind the scenes and all of that. And then we implemented a few requests. So we implemented three API endpoints, which is slash to-dos, which is get all to-dos. And the other one is getting a single particular to-do based on the unique ID. And the last one is create to-do. And we also talked about how we just have an in-memory data right now. So we don't have a database yet, but the video after this will be starting our database journey. So we'll actually connect a database to our REST APIs, and then we'll be actually dealing with that. So in the upcoming videos, we'll also talk about how we can actually deploy our application on the cloud so that everyone and anyone can access it and use the API. So that is for later videos. But for this video, let's start implementing our put and our delete requests. So let's start with put first. So let's make our simple endpoint controller for this. So we just have a request mapping, and the method is going to be equal to request method dot put. So pretty straightforward, nothing different here. And the value is going to be equal to slash to do slash ID. So only when we have the particular ID of our task, only then we can change it. So that is it. Next, what we have to do is make the method or code up the method. So we'll be having update to do, and now this will be having a path variable. So let's write that. Nothing extra here, just simple stuff which we have already done before. The path variable is going to be the ID. So the integer ID. Oh, sorry, my bad. And we'll also be having a request body where we have the updated things which you want to update inside our to do, right? So request body, and that's going to be a to do object called as to do. Great, awesome. So now we have our method ready, and all you have to do is just like post, we just have a to do call to the to do service dot update to do and pass in our object. Now obviously this hasn't been made yet. The function update to do hasn't been made yet, so we'll have to code that up. But this is how the controller looks like. So pretty simple, pretty straightforward, nothing complicated here, exactly like post, but we have an ID and we have a request body. So let's implement update to do now. So create method, and this is our auto generated stub to fill in. So let's fill this up now. So how do we actually update our task, update our to do object here in this array list, right? So what we can do is, instead of doing a filter and lambda functions, all of that, we'll just do a simple for loop where we loop through each and every to-do list object, and then we check if we have the one by ID. So we check by ID. So if the to-do.id is equal to the ID inside the list, then we update, or then we set the object at that place, or we replace it. So pretty simple, pretty straightforward. If you know Java, that should be more than enough. But let's actually implement it now. So for int I equal to 0, I less than todos dot size I plus plus, and now we are looping inside. Let's get the to do, todos dot get I, the index, and now let's check whether the ID matches. So if t dot get ID dot equals to do dot get ID. So if the ID matches, then we have to update our function. So let's see how that works now. So yeah, so I completely forgot about this integer ID, and I think the integer comes before to do. So let me just change that. Let me just fix this. Great. So let me see the to do controller. So the controller has two, right? My bad, sorry. So we have the ID comma to do. Great. So now instead of doing a to do dot get ID, we just do an ID. So it's much easier to work with. Yeah, now let's replace our existing to do, let's say 2, with the new object which we have. So all you have to do is do a to do's dot set. The index is I and the element is to do. And now that we're done, we return once that happens. So we're not handling a lot of exceptions and issues here for any of the REST APIs. We'll be doing that in the subsequent videos where we actually handle the cases where we are not able to find a to do. So we throw a status 404 and also give a user-friendly message. So we'll be doing all of that in the upcoming videos. But in the initial videos, let's talk about the basics that we need to understand about how MVP architecture in Spring works, and also how simple API endpoints can be made without dwelling much into it. So this is how the update works. So update to do, loop through all of them, get each object, compare the ID, and then replace it with the new updated to do object if you find a match, and then return. And that's it for update. And now let's start implementing a delete. So one delete is pretty straightforward, pretty simple, so we don't have to worry much about it. We'll just do it very quickly in like a few minutes, and then we can run the application and see our final a very simple hello world of CRUD right now. So again, let me just copy paste a lot of it here now. Then we don't have to write so much again. So we copy this again, and we just need to make a few changes. So this is going to be delete. Yep, and we don't need a request body because we just get the ID and we delete it automatically. And this has to be deleted. Yep, that's it. Let me just check. We request mapping, delete, and get it by ID, and then we just remove the ID. Great. So let's create the method in service now, and we got the stub. So again, the delete logic is pretty simple and straightforward, just like the update and the rest of them. We just have to loop through every single one again, and then delete the one which we get a match by the ID. So now that we have already done a for loop, let's do a lambda function again, because it's much more intuitive to do it with lambda function here, and you'll see why. So all you have to do is return. Okay, we don't have to return also, we have a void. So we do a to do's dot remove if, and we have a lambda function now. So for every to do object, remove it if t dot get ID dot equals the ID, and that's it. So since ID is unique, it will remove the ones which have the same ID. So again, if there's only one ID of one, then one is removed. So that's it. That's pretty much it. We just remove it if the ID is equal. So as I said, we are not doing a lot of, we are not handling a lot of issues and exceptions here because this is a very basic implementation, and we'll talk about or worry about them in a later video. So just to see what's happening here, we are assuming that the to do ID is unique, so we have to add that unique constraint here and the annotations, but we'll do that later. But the to do ID is later, then we remove it if there is a match, and that's pretty much it and how delete works. So let's run the application now and see if our implementation is right. So let me just run it before we actually use Postman. So run as Java application. And should happen about now. Yep, our laptop is really slow. I need to update it, but yeah, let's see what we can do about that. Great, so I think it is started on port 8080. So we have so let's get it first. So let me increase the size of this. Yeah, so let's get all the to-dos first. So we have 1, 2, and 3. Task 1, task 2, task 3, and now let's do a put on 1. So let's do it on 1 now. We'll do a put body is going to be for 4. Okay, so we already have 4 here, so I'll just be lazy and do it for 4. So summary 4 updated, and description also updated. The header is going to be application content type JSON, nothing different there, and we need an ID. So the ID is 4. So we're updating 4, and we just update the summary and the description. And now let's press send. We don't get anything here, but if you do a get on everything now, as you can see that, oh sorry, we didn't even have 4. Oh my bad. Yep, that was bad. Let's do a put again, and let's do it for 3 this time. Oh sorry, I completely forgot that we do not have 4. Wow. 3, 3, and yep, 3. Great. So we're not missing anything now. Let's do a send and get all of them. Send. And as you can see, we have updated a third one. And now while we're at it, let's delete 3 because 3 did not help us in any way. Anyway, yeah. So we have delete and to do /3. Press send. Again, we don't get a body back, but when you do a get again, you should see that 3 has been deleted. So yeah, as you can see, we just have 1 and 2. So this is how you actually uh, implement a simple hello world CRUD application using Spring Boot. In the previous videos, we talked about and implemented how we can develop a REST API using Spring and Spring Boot. We talked about how we can create our CRUD application, which is create, update, delete, and we also wrote the business logic or the business service for it, and we also had our controller and our entity. So let's just see the API in action before we jump on to the next concept. So here we have our to-dos, and we'll just do a get request to see how it works. And yeah, as you can see, we have our 3 tasks here, which we already had here. So until now, we have only worked with a database or a list as an arrays list as database, right? We haven't actually used a proper real database where we can actually save our data. So in the upcoming videos and in this video, we'll talk about how we can actually use an in-memory database, something called as Apache Derby, and also talk about in later videos how we can actually use an external database, for example, MySQL, Oracle, or anything of that sort, any relational database. So in this video, we'll talk about how we'll be actually using those databases inside our Spring Boot application. And the way it is being done using Spring in Java is by something called as JPA or Spring Data JPA. So let's talk about what JPA is first.
So here I have a really nice blog post, which the link will be in the description, where you can actually learn about what is JPA, Spring Data, and Spring Data JPA in detail. And we'll actually be going through this little blog post and understanding what all of these are. So let's have some background. So as you know, in the last decade or two, the world of data has seen a big growth. So there's a lot of databases here which provide a fast processing mechanism and specialized storage. So we have things like graph databases, document databases, key value databases, and column databases, rows and columns. So SQL, NoSQL, all of that. And while none of these are a one-stop solution to store all types of data in a single application, we have something called as polyglot persistence, or basically you use the kind of database that is required for your specific type of problem. So for example, if you have a very big e-commerce website, so the data for all of your product list will be stored in a JSON NoSQL format, and the account information for each user will be stored in a SQL database. So in a single application, we can have multiple databases because each of them have their own advantages and disadvantages. So we make sure that we know what the advantages are. Now, previously, the way you used to use SQL databases inside Java was something called as JDBC, and JDBC was fine, but you had to write SQL queries manually for every single logic or every single source that you have, and that caused a lot of pain. So Java has created something called as a Java Persistent API, which is a JPA. So this aims towards bringing consistency around accessing different databases. So before JPA, as we said, we use the JDBC API to query them. With JDBC, we have provided native SQL queries, and we had to write those string representation of SQL queries, which was not only tedious but error prone. And obviously, the query syntax may change when you change the database. So MySQL and Oracle might have some differences in their syntax, and you'll have to manually change them or write the queries when you actually use them as your database. So now, uh, now JPA is all about creating objects which can directly be mapped to the data objects. So the application will use JPA specification to push the object or retrieve the object from database, and this will be taken care all by the underlying JPA implementations. So we'll be using Hibernate in this case, and we'll talk about that later as well. So now this process of creating objects which can directly be mapped to the database objects, something called as object relational mapping, or OR. So with ORM, we use an API to query a particular database entity, and the result is provided in the form of a collection of Java objects. So you don't have to worry about how your object is being mapped to the database. The JPA takes care of that using something called as object relational mapping. So in our case, where we are building a to-do list API, we have a to-do object, and the JPA automatically map the to-do object with the database entity. So similarly, we just need to populate Java objects and pass them to the API. And the underlying ORM implementation is responsible for converting these API call into network SQL queries. So how that is being done, we'll be talking about that later. But let's first see what is Spring Data JPA. So Spring Data JPA is one of those many Spring Data projects which aims to bring consistency for all kinds of relational databases, be it SQL, Oracle, etc., etc. So now let's see what advantages we have when we use Spring Data JPA. So when we have a Spring Data JPA, we don't have to write a data access layer or any SQL statement at all, at least for the basic things which we need in our application. So based on the JPA specification, let's say MySQL, the underlying JPA implementation enables the entity objects and the metadata mapping. It also enables the entity manager who is responsible for persisting and retrieving entities from database. So as you can see, the Spring Data JPA is handling everything for you in the form of an API, and it already has its own underlying implementations. For example, Hibernate, which deals with anything that you want to do with your data, and we'll see how that works in a minute. So the Spring Data JPA defines repository interfaces which have the methods for storing and finding entity beans from the database. So it already has the implementations and the interfaces that you need to actually build your database queries. Now, while the interface only defines the query method, Spring at runtimes provides proxy implementations for the defined interfaces. So you will not be seeing these implementations, but when you use the function calls, you'll know that how all of these work, which is pretty basic, pretty simple, pretty straightforward. Now let's see how this works. Let's see how we'll be actually using this, the repository Spring Data JPA inside our to-do application with the help of an example. So we have something called as query methods, and the name of the methods declared in the repository interfaces are actually converted to low-level SQL queries by Spring. So here we have a very simple example of an employee repository where the employee will be having to do some basic functionalities. For example, finding all the employees, find by ID, find by first name, last name, etc., etc. So now, as you can see, this is just an interface. There's no implementation which the person had to write for this. You just need the employee object or the class, and for our example, it's the to-do class, and later we first do a simple function call. So by Spring, by the interface, you have something called as find all. So the find all method will simply be select star from employees. So the find all method behind the scenes is converted to the low level SQL queries, which is select star from employees. The second method pushes the where clause on the employee field, or find select star from employees where ID is equal to employee ID, something like that. Similarly for the third and fourth one. So this is how we'll be integrating Spring Data JPA with our application, where we won't be having to actually write a lot of SQL queries or any SQL queries. We'll just be taking up or adding in some function calls similar to this, not exactly this, but similar to this. And you'll see that in very less changes in the code, we'll actually have a working database inside our REST API. So now, how does this work? Let's actually start. So before we end the video for today, let's actually make a to-do repository. So a repository is basically an interface. We'll be having an interface which actually will set up all of this for us. So let's go to do new class, and we'll be calling this class to do repository and finish. In this video, we'll be setting up our repository, the to-do repository, and we'll see all about the extra dependencies that we need to actually build up our database, and also the kind of database we'll be using. So let's get started. So first, this is where we stopped in the previous video. We had made a to-do repository, which was the interface, and now we'll be doing very little changes to this interface. We will not be actually writing any interface function calls here. We'll just be extending from a different repository provided by JPA, Spring Data JPA, and we'll just get right ahead into using it. So, but first, let's talk about the database which we'll be using for the next few videos. So, the database which we'll be using is called as Apache Derby. So, Apache Derby is an Apache DB subproject, which is an open source relational database implemented entirely in Java and is available under the Apache license. So let's see why we'll be starting with Apache Derby and not MySQL. So Derby has a very small footprint, about 3.5 megabytes, which is really less for the base engine, and embedded JDBC driver. So this is something which we value a lot because it's very fast and it's very quick to actually have the database set up at runtime by Spring, and you just have to implement a service, implement a repository, and Derby and Java and Spring takes care of all of that for you. So we will be getting rid of that very bad arrays.as list function, right? So next, Derby is based on Java, JDBC, and SQL standards. So we will have Derby in a SQL standard, so we can assume that it will definitely have the SQL implementations behind the scenes. Now, since Derby provides an embedded JDBC driver, it lets you embed Derby in any Java-based solution, and that works perfectly because if you not only have a Spring Boot application, but you have a Spring Boot application that's communicating with a different Java application, and both of them are running Derby, then having this will be very easy for you to communicate with the other Java applications, talk to them, and also have a very simple connection where both of them work at ease.
Derby also supports the more familiar client server mode with Derby Network Client, JD Driver, and Derby Network Server. This is something which is out of scope for this video or tutorial, so we'll not be looking much into this. But if you want, the link for this will be in the description, and you can definitely go ahead. And by last, Derby is very easy to install, deploy, and use. So this is also very important for our REST API tutorial, because we want to learn how to build APIs and make sure that the database part is being learned on the way. So now that we're new to Derby, let's check out the start page and see how we actually get into it. So we have a lot of examples, demos, how to use Derby with other products, etc., etc. And the first thing which we need to do for Derby is to actually have the dependency inside our pom.xml. So let's open up our pom.xml and let's add in some dependencies for ourselves. So the first one which we need, dependency. Yeah, the first one we need is something called as Spring Boot Data JPA. So for that we need a group ID, and the next thing which we need is an artifact ID. Yep. Let me spell dependency correctly. Again. Great. So now we need to have the group ID and the artifact ID for Spring Boot Data JPA. So I have this right here already, so that we don't waste any time. So let me just pull that up. So here we go. So we have our Spring Boot Framework, which is the group from which we need it. So let's go and paste it here. The next thing which we need is the artifact ID, which is Spring Boot Starter Data JPA. So this is the name of the dependency, which is Spring Boot Starter Data JPA. So this is something which provides you all the database function calls, methods, classes, interfaces out of the box, just similar to Spring Boot Starter Web, which helps you start a Spring Boot project with very ease. So this will be actually helping us setting up our CRUD repository, which actually will help you get started with how to use it. Now, the next thing which we need, the next dependency that we need is obviously Derby, Apache Derby. So let's actually add that now. So again, we need to have a dependency, and let's close this. Oh, sorry, don't add starters. And cool. So we need a group ID, and the next thing which we need is an artifact ID. Great. And again, we spelled dependencies wrong. I don't know why I keep doing that, but great. And let's just copy Derby from here. So it's from org.apache.derby package. Let's go and paste it here. And the name is Derby. And we also have a scope. So let's just copy the entire thing and close this. So here we need this one. Yeah. So this is what are the two dependencies that we need to add to actually include Spring Boot Data JPA and Derby inside our application. And now that they are here, all you have to do is go to Maven and update project. And okay, so Maven actually gets the dependencies from the server and adds them to your Maven dependencies list, and you use it. So now let's see how Apache Derby works. So the best part about having Derby or using Derby is that this is it. This is all you need to do to actually have Derby configured and set up in your application. So basically, what Spring does when when you start the server, when you write all your when you finish setting up our database and you're writing all the function calls, etc., is that it looks at the POM and sees whether it has an in-memory database or an embedded database that it can use. And since we only have Derby inside our POM, it will assume that Derby is the one that we are using and set up and configure it for us at runtime. So that is how we take the how we use the power of Derby to actually build a Spring Boot application with the database. Okay, great. So now that we have our POM ready and we just need nothing else now, let's actually go and write some code to actually set up our repository. So as I said, we will not be writing anything inside the interface. We just have to extend from something. So it extends something called as CRUD repository. And let me just import it. And this will need two things in the implementation. The first will be uh, what kind of repository are we wanting here. So it's a to-do repository. So we need the to-do class to actually for it to map the things in to-do. So let me just open to-do. So we need to map the ID, name, summary, description, all of this to our application, right? So for that we need to give it a parameter of to-do. And the next thing which we need is the data type of the unique ID which we have. So for here, the unique ID is integer ID, which is an integer. So we'll just put this as integer, and we're good to go. Now, we told the CRUD repository that the integer is the unique ID, but we haven't specified that here. So all we need to do is just have an ID annotation for our integer, and that will automatically take care or tell that this is an ID, which is by Java X persistence. Great. So what did we learn or what did we do in this tutorial? So we had imported two things. First was Apache Derby, which is an embedded database written by SQL standard, which we'll be using later in the next upcoming videos. And we also added a dependency called as Spring Boot Starter Data JPA. After that, we set up our to-do repository where we extend from something called as a CRUD repository. So as you know, CRUD stands for create, update, delete. And this repository will handle all the interface and the implementation for all the function calls that we're going to make to, add a to-do, add a task, delete a task, update a task, or, add one task. And this takes in two parameters. One is the object, which we have, the single entity, to-do entity. And the next is the integer. So the integer here is basically the data type of the unique ID which we're using, and in our case the unique ID is the integer ID. So we need to mark the ID by saying that this one is unique, which we do by the ID annotation. So now this shows that in our to-do entity, ID is the unique key or the primary key for this scenario. So this is all we have to do. In the previous video, we actually set up our to-do repository and we saw how that happened. We set up our to-do repository with the help of the CRUD repository, which is given by Java Spring Framework.data.repository.CRUD repository. We also added the ID annotation to our ID for the to-do entity. And one thing which we forgot to do in the previous video is that we need to tell Spring Data JPA that this to-do class is an entity, so that it can be mapped to the CRUD repository for all the function calls. So all you have to do is give it an entity annotation, and we'll just import this now. One thing which we missed in the previous video, and I think we have covered that now, so that's nice. Yeah, so in this video we'll actually finish creating our integrating the database, the Apache Derby database with our application, and then run it on Postman and see whether we can actually do some post requests, some get requests, some update requests, and delete requests. So this is going to be what the video is going to be about. So first, all we need to do is that we need to make sure that we have the repository ready. So we have the repository ready, and the to-do entity is also ready. So let's close these, and no changes in the controller. The controller is going to be the same, no changes. And all we have to do is work with the to-do service. So let's get rid of our list now, or get rid of our database now. And yeah, now the first thing which we need to do is we need to add a dependency, which is the to-do repository. So we need to auto-wire it. So auto-wired and private to-do repository to-do repo.
So let's import AutoWire. Great. So we have our to repository here, and let's see how we can work with this or how we can actually use this. So the first is get all to dos. So now to get all to dos, we need to actually return a list of to dos, right? So first let's make a list of to dos. So list of to dos. So to dos equal to new array list, and yeah, we have created our list of to dos. So now let's actually query our repository and see how we can actually use the repository to implement get all to dos function. So let's see what a to do repository gives us. So to do repository dot, and as you can see we have a bunch of methods here. So we have count, delete all, exist, find all. I think find all basically says returns all instances of the type to do here. So I think find all works the best for our application here. So we'll do find all, and now that we have all that, let's add them to the to-do list. So for that we'll just use a simple function call again. So dot for each, and here we'll be using a different kind of Java syntax, which is to do's colon add. So this basically says that add for each to do which you find in find all, add them to the to do's list. So in this way, we have filled up our to-dos list, and all you have to do now is return to-dos. And yep, it's that simple. So all we had to do was call the function find all. So we haven't even implemented find all. So as you can see inside our repository, let me just get the one inside our project. My bad. So to service is here, to repository. Yeah. So we haven't even implemented any of these interfaces. We automatically get the implementation from Hibernate, and we use them with the Derby database. Great. Let's see how if we can do something. If we can find something similar for get a single to do by ID. So return to do repository dot, and as you can see, we got the first one as find one. So find one basically says retrieves an entity by its ID. So that's exactly what you want, since we have the ID as the parameter. So all you have to do is find one and the ID, and that's it. That's how we just return the to do which we get by the ID. And similarly, as you can see, we have a similar way of doing this for all the to do repository function calls. So again, let's return. Oh, sorry, we don't have to return anything here. We'll just do to do repository dot not dot count, sorry, dot, and as you can see, let's try to find the one which we need. So we need a save. So the save basically saves it to the database. So we'll do save, and the entity is to do, and that is how we create a to do. So pretty simple, pretty straightforward, nothing complicated. And yeah, just make sure that I haven't covered all the edge cases here. So this is still prone to breaking. The API still breaks. So if you don't pass in a specific value, something, we just get thrown an error. We haven't handled exceptions yet, but we will do that in the future videos when we actually have an external database included in our application. So until then, we will be working with simple functions and assume that all the API calls will be syntactically right. So yeah, don't worry about that. Okay, great. So next is update to do. So as you can see in the previous implementation, we used this in a very tedious way. So we loop through all of them, then we get the one which we want, then we check the ID, and then we update it. So instead of all of this, a very simple thing to do here is just to copy this one and paste it here. So this can be done in multiple ways, but this is the way which I found very easy to do when I looked up online on YouTube and other blogs. So basically, the same methods creates the entity and also overrides it. So when you pass in your to do with the update, all it does is it automatically overrides your update and overrides the to do object which you have in database with the new one which you already assigned. So that's all you have to do to update your
to-do list or to-do task in your to-do list database. The next thing which we have is delete. So again, pretty similar. To-do repository dot delete and delete by ID, and that's it. So that's all we had to do to actually use the to-do repository and uh, change the implementation so that this actually is being stored in a database and not an array list like we did before. So just to reiterate on the changes which we made for the database, uh, we went to do service. So yeah, we have the import is never used. Which one? So yeah, so oh my bad. Yeah, we don't need it if it's never used. Great. So now let's begin from the beginning. So first we made some changes to our entity. So we added the entity annotation so that Java X persistence or the database or the JDBC or JPA knows that we are actually using this particular class as our entity, which will be used for ORM, object relational mapping. The next thing which we did was create a new class or a new interface, which is today repository, which extends from CRUD repository, which handles all of your hidden implementations for find one, find all, save, and delete. And it takes in two parameters to confirm. One is the to-do object, the entity which we have here, and the unique ID or the primary key of our entity, which is ID and integer. The next thing which we did was make some changes to our to-do service. So we added a dependency for to-do repository using AutoWire. Next, we made the changes inside our methods to make sure that we use the to-do repository function calls. As you can see, it's very easy to read, very readable. Get to do is basically find one. Get all is find all. Create is save. Update is also save because it overrides it and also creates it. And delete is by delete. So now that we have finished making our simple REST API with Apache Derby as a database, let's run this and see this in action. So let's go here and run our application. So here, as you can see in the console, you'll see the database changes happening and how Spring is working at runtime to give you the Apache Derby function mechanism. So as you can see, building JPA container entity manager, Hibernate is being used behind the scenes for the implementation. Schema SL does not exist, so it's using automatically Derby, and we have started to do list on 8080. Great. So let's post something first. 8080 will post ID task 1 summary and hit send. And we get nothing in return, but the status is 200. Okay, so we have made it. Let's get and see whether it's did we actually make that one or not. So we do a get. As you can see, we got our first one ready. Let's do another post. So let's do another one. So 2 2 2 and 2, and we post this now. Let's do a get to check whether this has been post. Great. Let's do a put and update it. So let's do task 2 updated. Let me just do it for the rest. And let's do a send. Okay. Now let's go to delete and let's delete the one which you want. Let's delete 2 and hit send. Great. So and we do a get again. So get for slash to dos, hit send, and we just have one. So this is how we implement a to-do repository or a Spring Data JPA repository, and we use that with Apache Derby to actually implement the functions that we have here, which is find one, find all, save, and delete. In this video, we'll talk about how we can set up MySQL database with our Spring Boot REST API and what are the changes that we need to do in order to get that external database up and running. So, as you can see in the previous videos, we talked about how we integrate Apache Derby and embedded database inside our Spring Boot REST API application. And in this video, we'll actually move away from Apache Derby and actually integrate start integrating MySQL database into our application. And we'll see how easy it is to do that when you have a basic skeleton here. So since we were using the Apache Derby in embedded database, we wrote everything which we need to actually add some data into your database, right? So we have the repository interface, and we use that repository interface to extend from CRUD repository, and we also use that into our business logic and also the controller. So we have the skeleton we need to actually integrate any other database. So we'll be integrating MySQL, and in the upcoming video we'll also integrate PostgreSQL to our Spring Boot REST API application. So yeah, let's get started. So in this video, what we'll do is first set up our MySQL applications, so the way we can write MySQL queries, and also check to see that everything is up to date. So in this video, we'll talk about how we can set up the MySQL database for our REST API, and in the next video, we'll actually integrate that MySQL database with our Spring Boot application. So first, I'm currently using a Mac OS. So if you're using a Mac OS, then you can just do a brew install MySQL. You're using Homebrew, and install MySQL on your laptop. If you're using Windows or Linux, then please make sure to follow, or make sure to ensure that you have MySQL in your system before you continue this tutorial. Next, so one of the best MySQL UIs which I like is MySQL Workbench, because it makes it really easy to write queries, execute queries, and also see a lot of things which we need. So MySQL Workbench is a unified visual tool for database architects, developers, and DBAs. So we come under developers, I feel. So SQL development and comprehensive administration tools for server configuration, user administration, backup, and much more. So if you're having a SQL database to hold account client information, or basically when you have a login system in your application, you can use this to see those queries and data in your system. The next is that it's available on all Windows, Linux, and Mac OS X. So since it's cross-platform, I think it works well with any OS which you're using. So since we'll be using the developed functionalities and design, so we can create our tables. We'll be doing that in a minute, and then we can also customize user privileges, so that once you're actually deploying your API, you know what to do. So let's go ahead and start with creating our database. So I have MySQL Workbench open here, and this is how the UI will be after initial login. So here I have a SQL query file. So I just write SQL queries here and then execute them. So the first query which we need to do is create a database. So let's do create database, and the name can be to do DB. So we'll keep it simple. The next thing which we need to do is use that database. So use to do DB. Great. And the next thing which we need to do is create the table. So let's create the table now. So create table to do. No, so we'll call the table as to do only, or just to do. Yep, to do. And ID int not null, primary key, and auto increment. So just to make sure that we have all the right things we need. The next is title. Title, and it's going to be a varchar of 250. The next is summary, again a varchar of 250, and the last is description, again varchar for, let's say, 500 now. So this is our a few queries which we need to know before we actually start using integrating SQL. So what we did here is we created a database called as ToDB. Then we switched to that database, and then we created a table which has int
as the primary key, ID. So ID as the integer, title, summary, and description. So here, if you see our to-do entity, you will see that we have exactly the same. So instead of title, we have names. Let's quickly change that. So we don't need title, we need name, so that everything is right and all of the other things are good. So this is how we create a database and a table, and we'll be integrating this table with our entity. So we'll create an object relational mapping of this sorts with this table. And to make sure that the mapping is done correctly, we have the same column names as we have the class attributes. So let's run these queries. So for that, what you need to do is press Alt Shift and Enter. So let me just Alt Shift Enter, and this executes the query for you. So let me just show it to you. Yeah, let's refresh all. And as you can see, we have our to DB ready here. We have the tables as to do, and we have the columns as ID, name, summary, description. Great. Okay, so this is how you create your database. And the next thing which we need to do is play with the privileges a bit. So let me tell you what I mean by that. So first, let's write the query so that we get that out of the way. So we'll do flush privileges, and the next thing is going to be alter user. Let me just get this right. Yeah, root localhost, and we change the password to password. So one of the things which I noticed with my setup was that when I was actually writing the API, I didn't have any password set for root. So due to which the Spring Boot application was able to figure out where my database was. So that is why a very good solution, a very simple solution which I found online for Mac especially, is that you can just change your password to anything of what you like, and then use that in your application, which will actually help identify or get the database URL as soon as possible. So since I spent around I think like 2-3 hours wasting my time on how to figure out this, you can just use these two lines and you can just go ahead. And this, I think, is a problem with Mac OS users only. So anybody from Windows or Linux should not be facing this problem. But if you do, then this is a good solution for any operating system that you have. So make sure you flush privileges, and then you alter the root identified by your password. So for me, this will be password for now. And again, Control Shift Enter, and you have run those queries, and you're good to go. So now that we have finished writing our updating our database, what we can do is we can go up and start updating our application. So we need to first start with the pom.xml file and then work our way till the application properties. So we need a few things. So first we need to remove Derby Apache because we'll be using a different MySQL database, and we need to add a few other dependencies. So in the previous video, we talked about how we can integrate MySQL with a Spring Boot REST API application. In this video, we'll actually talk about the second part of the video of the MySQL extension, which is the changes which we need to do from the Spring Boot side so that we can connect the MySQL database server which we have with our Spring Boot application. So we won't be writing any code for this. The code will stay the same as it was for Apache Derby, and the only thing that changes is some application properties which are used to connect the Spring Boot application with the database, and a few dependencies, one dependency that actually helps connect MySQL to our to-do object, which is the object relational mapping functionality. So let's get started. The first thing which we need to do is add the dependency which we have. So let's just type it out. And the dependency is going to be having a group ID, of course. So group ID, and the group ID is going to be MySQL because that's the database. And then we have artifact ID,
and the artifact ID is MySQL dash connector dash Java. Yeah, and just to give it a scope, just to scope runtime. Okay, so this is the dependency which we need to make sure that MySQL knows which class to use to create an object relational mapping from. So this is how you connect MySQL to Java. Okay, so now that we have it, we just need to do a tiny change inside our to-do entity class. We just have to tell this class that it is linked to a table in the SQL database, and the name of the table is to do, right? So let's just check the name of the table. It is to db and to do. Yeah. So once we do this, we see that we add the PostgreSQL table import, and this tells MySQL which class to look at. So it'll scan all the annotations. It'll scan the table annotation, which is linked to the to do table inside MySQL. So this to-do entity is going to be mapped to the table. So yeah, just a quick change, or the only change in the code. Okay, so now that we have our dependencies and we have made that single change, let's actually go and let's delete this, and we'll just create it again. So we need to have a few properties inside our Spring Boot application, and these properties actually decide how we access and what kind of databases that we access. So this is called as you have already seen, application.properties. So let's create that right now. So application.properties, and make sure the spelling is right. Click finish. So this here you can override all the default settings by Spring, and you can have your own custom databases, custom build procedures, all of that. So let's write this to connect to our um, MySQL server. So since we have the TodoDB database or schema, so let's connect to that first. So we have spring dot data source dot URL equal to, let me just copy the address to the server, and it's to do TP. Great. So the first thing is basically the syntax, right? Whether the syntax is actually correct or not. So I'll have a link in the description where you can see the official syntax for this. What is happening and why. So let's just see this for now. Yeah, no error. And next, we need is the username and password. So let's just remove this and this. So we need the password and we need the username. So the username is root, and as I change my password to password, that is what I'll be writing. But obviously, there are better ways to write this point. The next thing which we need to do is tell which implementation to use. So since we are using MySQL database and we're using the JPA repository, but we're using only an interface, we need to select which implementation do we want. So there are a lot of implementations for this, but the most commonly used is Hibernate. So we'll be using that. So we just add that piece of property here. So we're using the Hibernate MySQL 5 NODB dialect, and at a single time the max number of clients that we can have is 10, so that we don't max out on these when you're testing it rigorously. So now that we have the property set, so here we connect to the TrueDB MySQL database. This is how we connect the external database with our Spring Boot application. And once all this is set, all you have to do is just run the server again. So let's go and run the service, the Java application. Yep. Let's wait for this to run. So this is
establishing the connection, and so I think we got some errors. Let's see them first. What the errors are: could not create connection. Okay, let's see what caused that issue. So right here, let's go up. TrueDB is right. Yep. And Hibernate max full size 10. Now this is looking good as well. Let's see what the error was. So if you go to Spring Toolsuit and see the error, could not create the connection because that cut. I got to know what the problem is. So in our pom.xml here, we need to add the version as well. So it's a version issue here. So let's add the version, which is 8.0.11, and just let go of the errors for now. So if these errors pop up here, all you have to do is ignore the warning for now, and let's run the application again. So let me just check the version again. Yeah, let me just check the version again. So I think, yeah, 8.0.11 should work. And let's run as application. And yeah, I think we're good to go. So the database is set up and the URL are also mapped, and we have the server ready. So I have already added nothing here. So let me just add some things. Go to post. Let's add two first, just for the sake of it. Okay, so now that two is added, let's do a get and let's send. As you can see, we get two back. So this is how, without updating any single piece of code, we're able to actually integrate SQL, MySQL with our REST API application. In this video, we'll talk about how we can update our to-do entity and also update our database so that we can know how do we handle situations where we have to update the database, add a column, or remove a column, or also make any changes in the database, and how the database changes should reflect our code and the entity changes. So first, let's get a recap of what we had done in the previous videos. So we have our to-do API. So we have the to-do service, we have the repository, we have the controller, and we have the entity. Now, the entity had ID, name, summary, description. So this is the four attributes which our to-do entity has, and this was controlled by our CRUD repository to make sure that we don't write any native SQL queries. And we talked about this in detail in our previous video. Apart from this, we also have our service, which controls all the business logic for our application, which is pretty much CRUD, so which is create, update, delete, nothing fancy here. And next, we have a controller, which basically handles all of our API endpoints, so slash to do ID, and the put, post, delete requests of that sort. Now, all of this was initially handled using an in-memory database, which was basically a list, a simple Java list. Then we moved on to Apache Derby, which was an embedded database inside Spring Boot, and we were able to actually eliminate the list code using that. And after that, in our most recent videos, what we did was we had an external database, which was MySQL, and we were able to connect MySQL to our database using the application.properties file. So we had this little file which had all the URL, username, password, and the properties which are required for a database to be connected to Spring Boot. So now in this video, we'll actually update or change our structure of our data so that we can see how what places do we need to change so that these changes can be fitted into our application seamlessly. So the first thing which we need is that let's say I want to make this to do API access or being able to be used collaboratively. So suppose I have a to do list and I want to send that to a friend of mine, and I send that to a couple of friends. All of us collaboratively work to solve or to finish that to do list, and there should be an author of all of that to do list, right? So let's add an author to our entity. So we have string author, and let's make our changes inside our constructor. So we need to add author here, add an author here as well. And the next thing which we need to do is make getters and setters for this. So we need to do a public string get author, which returns author. And now we need a setter. So public void set author, and all this does is instantiates our author. So pretty straightforward, nothing complicated as of now. We just added the author attribute to our to-do entity. So what's the problem here? Yeah, sorry, string author. So we just added the author to our to-do entity. Nothing different, nothing complicated here. And as you can see, we don't have any other changes to be made. So if you see the controller, we are not explicitly accessing the to-do object and the attributes inside them. So here we just handle the to-do object as it is. So the object inside consists of all these attributes. So nothing explicitly handled in the controller, nothing in the repository as well. We just have the entire object and the integer, which is the ID. And for to-do service, we also have nothing explicitly being handled. So only change we had to make was inside here, and we are good to go. So this is the change which we had made from the core or the API side, and now we need to make the same change in the database, right? So open MySQL workbench and make sure that you're connected to your root and have the to-do DB ready in your schema. So now we need to alter the table to add that column, right? So we do use to-do DB so that we're using the to-do DB database, and let's write the query. So it's alter table to do and add author. It's going to be a var char of 64. Yeah. So this is our query. So let's run the query now. So all we are doing is altering the table to do. We are adding author column of varchar 64. So let's just do a run and let's refresh our schema. Let's go inside tables to do columns, and as you can see, we have our author ready. So now that we have an author ready, all we have to do is basically run our function, run our API. So let's run it right now. So we have initialized our entities, we have mapped the URLs here, and our API is started. So let's go to Postman and let's do a get first. So we'll just do a small get and see what we already have inside. So I'm doing a get. Let's see what we already have. So first we have just one here. We just have a to do of task 2 with author null. So the author has been added now. Let's do a post and have a body. Let's do an ID 3 task also 3, summary 3, and the author is going to be me, so Ronak Vyas. And let's just do a small post and see if that works. So the status is 200. Okay, so I think we executed that. Let's do a get and see what happens. So we do a get and hit a send. Yeah, as you can see, we have added the author as Ronak Vyas. So that is how we actually make changes to our database and also our REST API. So first you need to make the appropriate changes inside your Spring Boot application, and then once that is done, you can make changes to your database. So usually you make the changes to your database to your Spring Boot application first, because suppose you're working with a lot of people in your team, and everybody in your team is working on the same code on the same database as well. So if somebody is trying out a new feature, then the database is currently being in used. So if you make a new column and then alter the database and add a new column and then start working on your code, somebody who is working on a different feature will not be able to actually access your database, right? Because you have a new column which the person does not know anything about because it's a different feature altogether. So what my suggestion is that first work on the code, make sure that the code is up to the point where you're confident that you can actually make changes to your database now. And once you're confident, then make the change to your database and just let everybody know that I have made this change in your database, and you need to use this so and so and so, and keep working. So in this video, we'll talk about how we can integrate PostgreSQL with our Spring Boot REST API application. So the usual way of doing this is by first downloading the PostgreSQL database, and which you can do it on this link. And once it's done, make sure that you have a PostgreSQL UI from which you can actually add and remove your tables, add database, etc., etc. So I will show you what you can do to actually download this and how to also download the PostgreSQL UI. So I currently use a Mac. So for that, I use a Mac OS operating system and I download the package. Once it is done, PostgreSQL gives you a very nice and handy UI using which you can actually spawn a terminal of your own for each and every database which you have, and then use that to actually use your PostgreSQL database. So let's get started. The first thing which you need to do is download PostgreSQL, and once you're done, let's open it up now. So it's the Postgres app, and yes, check automatically. And as you can see, my server is running now, and you'll get PostgreSQL by default as a database and also a template one. So first, what we do is click on template one. So let me just take this one as my database, and just to show you what happens. So once you click on that, it opens a nice terminal. So let me increase the size of the terminal. Yeah, so I'm inside the template one database, and if you want to see the tables inside now, you can see that there are two tables, to do and to do, which I've made, but we'll make another table using which we'll be integrating our Spring Boot REST API application. So this is how the terminal looks, and make sure that you have PostgreSQL downloaded and installed before you start the video. So yeah, now that we have our PostgreSQL database, the next thing which we need to do is make sure that we update our application properties, because this is where the major changes of our application are to be done. So if you are new to this video and new to the Spring Boot application REST API videos, then make sure to watch my playlist on this channel, and I'll just give you a quick overview of what is happening in this REST API application. So this is a to-do list API, and you have a to-do entity here, which is going to be using these attributes. It's going to have an ID, title, summary, description, and all of the stuff, setters and getters, parameters, constructors. This is then controlled by a to-do controller, which has the API endpoints for our to-do list API. And the business logic resides in to-do service, which has everything from get all to-dos, get to-do, create to-do, etc., etc. And the last thing is the repository, which handles our implementation for JPA, in this case Hibernate. So we'll be using this to actually make sure that we have our basic implementations for save, find all, etc., etc., ready. So this is how our API is in a nutshell.
So the first thing which you need to do after you have installed Postgres is first have the PostgreSQL dependency. So this is the dependency here, and just install it. Remove the Spring MySQL dependency that you have. Just make sure you have PostgreSQL, and should be downloaded within no time. And then right click, go to Maven, and click on Update Project, and it will automatically have it in your Maven dependencies. So when that is done, the next thing which you need to do is change the dialect. So is basically how Hibernate implements its native SQL queries for you. So the Hibernate dialect for PostgreSQL is this. So I'm just copy it from here. I just did a Google search for this, nothing complicated, and just paste it here. Great. The next thing which you need to do is change your URL. So let me just do this for now. We don't need the username and password. We just need the database location. So let's see how you can generate a PostgreSQL. Yeah, right here. So this is how it looks like, your PostgreSQL URL. So we need JDBC. So JDBC is your API which connects it to your application. And now that we have done this, we need to go into template one. So template one is our database here, which we are accessing using this terminal. We are template one. Okay, so now what we have to do is create a new table. And let's say the name of the table is going to be to do table. Not the best name, but we'll make do for now. So now that we have a to do table name, so let's do it to do table. We need to make this table inside our template one database. So for that, what we can do is we can do a create table to do table, and then have all of our attributes. So first we have is the ID. So ID int primary key. Next is going to be the title. So title varchar 64. The next thing is summary varchar 64, and the last thing is description varchar, it's going to be 64 as well. So these are all the attributes that we have inside our to do table, and let's hit enter, and you see that it has created a table. Just to confirm if the table has been created or not, let's do a /gt. As you can see, you have a to do table as your table inside your database. So now that we have made our to do table inside it, make sure that the name is also the same here to map it to your object, which is called object relational mapping. This is ready. The form is ready. We don't need the controller now, and all you have to do is now run your Spring API, and let's see that it has actually started our implementation of connected PostgreSQL successfully or not. So as you can see, this server is spawning up. No errors so far, so we're good to go. And yeah, we have started the to-do list server. So now to check whether our database is working or not, go to Postman, do a get of to-dos, which should give us an empty list for now. So as you can see, an empty list. So let's add some data. So do a post body. I will give it as 1. Let's have the task as do lead code every day, or let's just make it a bit funny now. 1 lead code a day keeps unemployment away. Great. The summary is going to be invert a B tree. Description same as summary, and we don't need the author for now. So this is how our ID is, and let's post this now. So do a send, and the status is 200. Okay, so let's do a get, and we should be getting our data back. So yes, I think I missaid the title a bit, but this is how you actually connect your PostgreSQL database to your Spring Boot application. So let's rewind and see what we did here. So the first thing which you need to do is download PostgreSQL for your operating system. After that, open it up, you'll be having PostgreSQL, and then if you want, you can initialize a new database. Make sure you double click on that and then connect to your terminal. Increase the font if you want to, get really, really small. And once that is done, you can then create a table here as I did. Go to your application properties, change the dialect and also the URL, and you're good to go. So that is how you integrate an external database as PostgreSQL into your Spring Boot application. In this video, we'll talk about how we can integrate caching in Spring Boot using caffeine in-memory cache, and we'll also look at what caching is, why do you need a cache, and how can a cache actually speed up or increase the performance of your application through various approaches. So before we move on to how to implement a cache and looking at an example, let's talk about what caching is. So this blog post by AWS on caching is a really, really nice starting point to understand how caching works. So please check it out, and I'll have a link in the description as well. So in computing, a cache is a high-speed data storage layer which stores a subset of data, typically transient in nature, short-lived, so that the future requests of that data are served up faster than it is possible by accessing data's primary storage location. So what does this mean? So let's say that you have a very expensive data object in your database, which when you fetch it from database, it takes a lot of time. So what you can do is you can use a cache where you only fetch that expensive object once, keep it in the cache, and in the future requests, the data will be served through the cache and not by the database. And the cache is in memory, so it'll be really, really fast to actually get that expensive object from your to your application. So how does caching work? The data in a cache is generally stored in a fast access hardware such as RAM, and will also be used in correlation with the software component. The primary purpose of a cache is to increase data retrieval performance. So this is very important. To increase data retrieval performance by reducing the need to access the underlying slower storage layer. So in our example where we had an expensive object inside database, our slower storage layer would be the database, and we use an in-memory cache to actually increase the data retrieval performance. Now, the next thing which you need to know is the benefits of caching. So we have an improvement in application performance, reduce database cost. So this is what we'll be looking at. Reduce the load on the backend, increase throughput, eliminate database hotspots, and predictable performance. So when you use a cache inside your application, whether be it to cache the application, cache the load balancing, cache the database, you will see a very nice increase in your performance and scalability. And of course, this also depends on different factors of your application and also the kind of configurations you have with your application. So now let's actually look at how we can implement an in-memory cache in Spring Boot using Caffeine. And if you want a really thorough example, then please go through this blog post where they explain how you can implement a cache in a REST API. But we'll be looking at a very, very, very simple example, sort of a hello world of caching using Spring Boot and Caffeine. So let's jump into that. So yeah, before we start going to the example, you definitely need these two dependencies in your application. One is Caffeine and the other is the Spring Boot starter cache dependency. Okay, so here I have a very simple application which uses a cache, and we'll go through this application, run the application, and see how the cache is being implemented here. So if you want to know how to write the code to implement a cache for your application, then there are a lot of tutorials on YouTube where you can actually see how to implement it. This one deals with understanding the cache and how the configuration and how the system works in Spring Boot. And we'll be using the caffeine cache as an example here. So first we need to configure our cache and add it to our cache manager by Spring Boot. So this is what this code does, or config file does. Here we have a caffeine which we are building. The initial capacity is going to be 100, maximum size can be 500. The element in the cache expires after access in 10 minutes. So
if it's been more than 10 minutes since the last time the limit to the cache was accessed, then it automatically expires. And you have the record stats method, which basically gives you the statistics of your cache. For example, the eviction count, the hit count, etc., etc. So this is how a configuration for your cache config works. The next thing which you need to do is two things. First, we need to enable caching for our application. Tell Spring Boot that we will be actually using a caching mechanism inside our application. And the second thing is pointing to which method will we be caching, and we have to tell Spring Boot that. So let's see how we do that in the application. So you can Spring Boot has an annotation called as enable caching, which you can add to your application or even to your configuration file. And this tells Spring Boot that please look at all the dependencies that involve caching in the class path and use the ones which you specify. So we have specified the caffeine cache here, so we'll be using that and searching for caffeine dependency in the class path. So we have that in our POM. Let's just look at that here. Yep, we have it right here. So this is how we tell Spring Boot that yeah, we want to enable caching for our application. The next thing which we need to do is tell Spring Boot which method to be cached. So here I have an example service which basically gets you a string and it tries to simulate an expensive DB fetch or database fetch and return the string back. So you can think of this as an example where we are fetching a really expensive object from the database and then returning it back to the user. Now, since this is going to be expensive, we add a cacheable annotation on top of it, and now every time we access this method, the return value will be added to a cache, and this cache is in the form of a hash map or hash table which has a key value pair, and the value inside your cache is going to be the return value here, which is going to be a string. The last thing which you need to know is cache config, which is basically the name of the cache which you want to use. So if you see the config here, we are using an example cache, which is the name of our cache, and we just point out to Spring Boot that this is where we actually want to use example cache. So now when we actually test our application, we will see that this line of code will only be seen once, because once we fetch it from the database, it will be inserted into the cache, and then we will only be getting this result without actually going through the DB calls inside this hypothetical method. So now let's see our actual method where we try this out. So we have autowire or injected our example service. We start the caffeine cache testing process. We call the get string method, and since it's the first time, there is no hit to the cache. This is a terminology where we use for caching. When we actually access the cache, it's a hit. When we don't access the cache, then it's a miss. And when the element is removed from the cache, it's called eviction. So the first time when we do this, it will actually hit our database, and this will be printed out. From the subsequent times, here we have a hit, so this piece of code will not be shown again. So let's see how this works, and we can run it here, and we are looking for this to not be there inside our application. Should be the only ones. So let's do it here, and as you can see, we have the simulating log only once, and subsequent times we just call the expensive string inside our function. So this is how you implement a very simple introduction on how a caffeine cache works in Spring Boot, and how you can actually run this code and figure out how to use caffeine cache or a cache inside your own application. So that is all for this video. The code for this example will be in the link in the description, the GitHub repo. You can definitely check it out. Thank you for watching, and I'll see you in the next one.